Good morning, student. Today we'll be discussing on Newton's second law of motion. Before we go for the statement of second law, we have to discuss few common examples from our daily life. In the last class, we have discussed about Newton's first law and the concept of inertia. Inertia was that tendency of an object which resists any change in its state of motion, and inertia was measured by the mass of a body. So, more massive is the body, it will have more power to resist in its changes motion. Now, let us take an example. A man is standing and two vehicles, one bicycle and one truck, unloaded. So, one truck, both of them are moving towards him with a very small velocity, say for instance 1 meter per second. Now, asking you that which vehicle will hurt him more. Now, here we have to stress on the word hurt. Hurting means applying more force. So, which vehicle will apply more force on the man? Obvious answer, I know. You will say the truck will hurt him more. Why? Because truck is massive. It has more mass than the bicycle. So, we agree, all of us are agreeing on the fact that massive body has more power to exert more force on something. Okay. Now, we are taking a second example where two bicycles of same mass is heading towards a man with different velocities, one with 1 meter per second and one with 3 meter per second velocity. This time if I ask you which will hurt him more, you will say that the second one will hurt him more. Why? Because it is coming with more speed. So, all these are coming from our daily life experiences. We did not calculate anything. We know this, we have seen this, and that's why we are concluding these facts. So, can we say from the second experience, can we say that velocity of a body is also contributing a lot to the force? So, force exerted by a certain object, it is determined by two factors, one is mass and one is velocity. Incorporating these two facts, a new physical quantity was derived which is known as momentum. Momentum, the definition is given on the slide. It is defined as a product of mass and velocity. This definition you have to learn. If a body of mass is moving with velocity v, where the mass is m, the momentum will be denoted by the letter p. P is equal to m into v. Momentum is a vector quantity. It has a proper direction and magnitude, of course. And SI unit of momentum you will not learn, you will derive. Where from? From that equation which is written in red, P is equal to mv. SI unit of mass is kg and SI unit of velocity is meter per second. So, we are multiplying them, we are getting the product of m and v, similarly product of kg and meter per second. So, SI unit of momentum is kg meter per second. Let us now discuss about Newton's second law of motion. It states that the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in a direction in which the force acts. Now, Newton's first law, it is giving us a qualitative analysis on the concept of force. Qualitative means descriptive analysis. And Newton's second law gives us a quantitative analysis of force. That means we can measure force by using the concept of Newton's second law. Now, mathematical expression of Newton's second law will be derived here. For that, we are considering that a body is having mass m which is moving with initial velocity u and final velocity v. So, the momentum P is equal to mass into velocity, as because the body has two different velocities u and v, similarly it will have two different momentum, initial momentum mu and final momentum mv. And this, we are going back to the statement once again, that is the rate of change of momentum. Here the word rate means unit time, the change in momentum in unit time. Now change means final value minus initial value. So change in momentum is mv minus mu, and when we are calculating rate, mv minus mu by t, that is the rate of change of momentum. And from second law statement, we know that force is directly proportional to it. So F varies as mv minus mu by t. We are taking m as common. So we are getting F varies as m into v minus u by t. And from the definition of acceleration, we know that v minus u by t is equal to a acceleration, and that's why F varies as ma. And we know that we cannot work with the proportionality sign, so we have to convert it to equal sign for calculation. So we are multiplying that with a constant k. So F is equal to kma. So we are continuing with that derivation. K is the proportionality constant. Now here we are defining the SI unit of force. One unit force is defined as the force which is applied on a body of mass 1 kg, and it can produce an acceleration of 1 meter per second square in the body. So 1 unit of force is equal to 1 kg into 1 meter per second square. So if I put 1 is equal to k into 1, so we are getting the value of k as 1. By putting the value of k is equal to 1 in the previous equation, we are getting F is equal to ma, or force is equal to mass into acceleration. This is the mathematical expression for Newton's second law. With this equation, we can calculate any force. Now, SI unit of force, as we all know, it is Newton, and it should be written in small letter. Newton, when it is written in capital letter, it is actually meaning Sir Isaac Newton, the famous scientist. But when it is written in small letter NEWTON, it is giving us SI unit of force, or we can write it simply capital N. Now, how can we define 1 Newton? 1 Newton is defined as that force which, when applied on a body of 1 kg, can produce an acceleration of 1 meter per second square. It is shown in the figure itself. Hope you understood this concept. Let us discuss about few applications of Newton's second law of motion. These are the very common question comes from this chapter. So please understand it properly so that you can write it on your own. Now it's a very common experience that fielders in a cricket field, when they try to stop a ball, they pull their hand in backward direction. Now the ball is coming to the fielder with a very high speed. Either it is hit by the batsman and the speed is quite high, or it is thrown by a bowler with a very high speed. The fielder has to catch it. So initial velocity of u of the ball is very high. So obviously initial momentum of the ball is also very high. Mu is very high, but the fielder is trying to stop it. So what is the value of final velocity v here? Final velocity v is equal to 0, and final momentum mv will also be equal to 0. So according to Newton's second law of motion, force is equal to mv minus mu by t, where mv is 0 and mu is quite high. So we are getting 0 minus mu by t, or minus mu by t. Now I am going to mathematics a little bit. If we compare between two fractions having same numerator, suppose 5 by 2 and 5 by 3, both have same numerator, so which one will have greater value? Obviously, the one with lower denominator will have a greater value. Let us take one more example. I am having a pizza, a large size pizza, which is cut into 4 pieces, 4 slices, and another same size, large size pizza, which is cut into 8 slices. So, which one will you prefer? If you love to eat pizza, obviously the first one, because it has got only 4 slices, but individual piece will have more pizza in it. But the one which is having 8 slices, the individual pieces will have less amount of pizza. So, keeping the numerator same, if the denominator is more, the fraction value reduces, or vice versa. Keeping the numerator same, if the denominator is less, the value of fraction increases. Okay. So, if the ball is stopped suddenly, the momentum will be reduced to 0 instantly, causing the instant rate of change of momentum, due to which the force will be quite high. So, I have underlined the line, that is the key line of the answer. Whenever you see the diagram, second diagram of the fielder, he is pulling his hand backward. So, the ball is getting more time to get stopped. So, whenever it is having more time, automatically the denominator increases. Obviously, the value of force will be reduced. And I already said in the previous slide, getting less injured means less force is applied on it. So, by increasing the time, less force will be applied on the hand of fielder. So, probability of getting injured will be less. So, the key word of the answer is, by increasing the time, the fielder is reducing the force on his hand. Now we will be discussing the second application, that is the use of seat belt. We all know that seat belt is a safety measure which is taken in a car, but why we are using it? Now, whenever a man is traveling in a car and the car suddenly stops, the body of the man, the upper part of the body, due to inertia of motion, it tries to move forward, and it may hit the dashboard or the previous seat and he may get injured. To prevent this kind of injury, we are recommending to use the seat belt. Now, whenever the car is moving with very high speed, the initial momentum is u is very high. So, initial momentum mu will be very high and the car is stopped. So, final velocity v is equal to 0. So, mv is equal to 0. So, change in momentum will be mv minus mu. So, 0 minus mu, and force according to Newton's second law of motion, F is equal to mv minus mu by t, that is equal to 0 minus mu by t, or is equal to minus mu by t. It is similar to the previous one. But whenever we are using a stretchable seat belt, what is happening? I am giving the body more time to fall in forward direction. So, when I am increasing the time and increasing the denominator of the fraction, so the value of the fraction, that means the force is reduced. Force reduced means with a lesser force the body is moving forward direction. So, the probability of fatal injury is reduced. Similar example is given here. For athletes of long and high jump event, a sand bait or cushion bait is provided at the place of landing. You can see it in the animation. This is Indian athlete Deepa Karmakar in Olympic. You have seen this many times in TV. This is because when the athlete falls on the ground after performing high or long jump, the momentum of his body was initial momentum is very high, but the final momentum is reduced to 0. So mu is very high and mv is equal to 0. According to Newton's second law, F is equal to mv minus mu by t. 0 minus mu by t, that is equal to minus mu by t. So whenever I am providing a sand bed or a cushion bed, so automatically the time of falling is increased. So when the time of falling is increased, the denominator is increased, the force is reduced. With lesser force, the athlete is falling on the cushion. So what happened? The probability of getting injured is becoming less. Now all the three examples, the similar way we are explaining it. In the book you will not get this part, the mathematical part is not given, only the explanation will be given. But I will suggest all of you to incorporate this mathematical part in your answer. The answer will be complete if you provide with it. All right. Now we have some questions on Newton's applications of Newton's second law of motion. So let us discuss all this and try to solve. If you have any difficulty, ask me in the class. Thank you, children.